Hey, what is up guys? Mason here. Just coming in with a quick tutorial on how to make a simple bootloader that loads a dummy kernel. Alright, and x86 assembly, by the way. This is x86 assembly. So, basically, what we got going on here is we got the origin set to 0x7C00 in hexadecimal. And this is basically telling the bootloader that we want to load in our boot sector at this address. I'm pretty sure that's what that means. We are setting the bits to 16, so we're in real mode, 16-bit real mode. Alright, and then we got our main boot function here. So basically what we got going on inside this function is we are moving 0x02 into the register AH. We are then moving 0x01 into the register AL, and so on and so forth. I don't want to go through all of them, but basically if we look at the docs on OSDev for ATA in x86 real mode, we can see to read sectors with CHS address, we want to set AH to 2, which is what we did. AL is the total sector count. So basically we are only going to be reading in one sector off the drive. CH is a cylinder, so we set that to 0, cylinder 0, because everything is 0 base. It starts at 0 usually. And then the sector, we are reading in sector 2. And this is because the bootloader is technically at sector 1, sorry. It's at sector 1. So to load in the kernel, we need to read in sector 2. Drive head, I have that set to 0. As you can see, drive head is DH. I have that set to 0. We are when you move a hex address into DL, that's basically the the drive number. So it's 0x80 for the drive C or your hard disk, and it's 0, as you can see, which I set for a floppy, and I'll get into that in a second. And then BX is our offset address. We then move BX into ES, and we call interrupt 13. If you guys want to check out the interrupt list, I'll show that to you real quick. C time, I believe. Ralph Brown's interrupt list. Oh, whoops. Categories. Looking for BIOS, right there. Disk write sectors. Is that what I'm looking for? No, disk read sectors in the memory, yeah. So as you can see, it uses interrupt 13 with AH set to 2 hexadecimal, which is what we did. AH is 2. We're using interrupt 13. Alright. So if that doesn't work, we then call disk error. And in the disk error function, basically, we are just printing out a exclamation mark. And then we're halting to basically say that, hey, we couldn't load the kernel. Otherwise, if this works out successfully, we move down here, then we're basically printing out a $sign. And then we're jumping from offset 1000 in hex to 0 in hex. And if we go look at our dummy kernel file, we'll see that our origin is set to 0. And as you can see, we're jumping from offset 1000 to 0. Also bit 16, we're in 16-bit real mode. Global start, that's just for the GCC compiler. I'm not actually using the GCC compiler, but I feel like it's just common practice to do this. I could be wrong. I'm kind of new to assembly myself, but yeah, I'm pretty sure this is, common practice. And then we got our start function. In our start function, we are basically, this is basically the kernel. Once it's loaded, we are just printing out a question mark, and then we're jumping to the done function, and in our done function, we're just halting. And this is our magic number. Well, this is the magic number telling it that it's bootable. And we're basically just setting zeros after 512 bytes in memory. I'm pretty sure that's what that means. All right. So, as you can see, I already have some files compiled here. So let's go ahead and check that out real quick. Basically, what you want to do is you want to, let me just clear this. Basically, what you want to do is you want to run NASM. If I can find it. You want to run, geez. Did a lot with the dummy kernel. All right, so you want to run NASM on your boot sector, on your bootloader, basically, right? Do that. Then you want to run NASM on the dummy kernel. Do that, and then we want to concatenate the boot sector and the dummy kernel. As you can see, I have the boot sector first, and then the kernel after. And this is important because first we are loading in the bootloader, and then we're trying to load into memory sector 2, which dummy kernel is going to be sector 2, so we want it after the bootloader. So do that. Then we want to dd. So I have this concatenated into a file called testbin. So I'm basically taking bootsec.bin and dummykernel.bin, and I'm concatenating it into a file called test.bin. And then after that, we want to dd test.bin into a file called bootsec.floppy, and I'm making this a floppy. And the reason why I'm doing that is because I'm reading from disk 0, which is floppy. So we do that. Works successfully. Then we want to load up QEMU. Sorry, I don't know. QEMU, I don't know. System x86-64, FDA is telling it to load from the floppy disk. Yeah, and we're loading in our floppy disk image. And if we run this, you can see at first we get the $, which is saying that it, it was able to go through all these calls correctly. And then we load the kernel, and in the kernel, as you can see, we've got the question mark. So this bootloader successfully loads in our dummy kernel. And you can do really whatever you want with this. This is simple OS development, really at the basic level. If you wanted to basically expand your kernel into a functioning operating system, this is, a good start. But yeah, thanks everyone for watching. Just wanted to show a quick tutorial on how to go about basically setting up a bootloader and reading a kernel into memory. In this case, a really simple dummy kernel that just prints a question mark. And this bootloader is really simple as well, but it's, it's a start. Anyways, thanks for watching, guys. Catch you in the next one.